Hey ChemStars, this is Mrs. Vandeloy bringing you ChemStar video. This is section 2.3.2. This is a really important section. This is significant figures and measurements, okay? And this section is going to tell you how to round your numbers, okay? So when we divided things in the density section, all right, we really didn't have a clear-cut way to explain how to round these numbers, okay? So that's what this is all about. What is our purpose? I can use the correct number of significant figures and reporting measurements and the results of calculations. Okay, so we are not just going to look at the number of SigFigs, we're going to do something with them. That's what this is all about. So do you remember, before we did the graphing, we talked about error and we learned how to read a ruler? This plays directly into that, how do you read a ruler? So your significant digits represents really how precise your instrument is. Okay, so remember when we had like the ones unit in our ruler and we could read the nearest hundredths? That's what we're talking about. So each one of those values is significant. We're going to use those for our calculations. So what does it say? Significant figures reflect the precision of the instrument, the scale, the graduated cylinder, the ruler, the thermometer that is used to record data, and measurements must always be reported to the correct number of SigFigs because calculated answers often depend on the number of significant figures and the values used in calculations. So that's what reading the ruler is all about. Measurements must always be reported the correct number of significant figures. So when we look back at our rulers, we measure nearest hundredth. That's what we're talking about. So the ones, the tenths, and the hundredths are all significant, and we're going to use that to calculate. Okay, so we are only talking about measurements. If I'm just talking like in math class, we just take a bunch of numbers and do something with it. That's not significant figures. It has to do with a measured quantity found from a lab. Okay, that's when you have to use significant figures. All right, so what does it say? Rules for significant figures. Any number has an infinite significant figure, meaning like in most math classes, okay? So this would be like the number 2. You double a measurement. So we can have like diameter is 2 pi r. That 2 in the pi has infinite number of significant figures. The only one that matters is the radius because you measured the radius with a ruler, okay? A definition has infinite significant figures such as 3 feet in a yard. You didn't measure those 3 feet in a yard, it's a definition. Now, number 3 is the biggie. Measurements are the main ones used in science. Any non-zero digit will be significant. It couldn't be a digit if it weren't measured. So the zeros are the tricky part. So start learning these. So when you're practicing them, have these rules handy. All zeros between non-zeros are significant. So the 0 between the 5 and the 8 are significant because you measured the 5 and you measured the 8. Zeros at the end of a large number, but before an understood decimal point. There is no decimal point, you just know it's there, are not significant. So what does this say? It's about, did you hear me? About 23,000 grams. What if I wanted to be exactly 23,000 grams? Then guess what? I would put a decimal point here. Oops, sorry. A decimal point here, and that would be exactly 23,000. But without that decimal point there, I'll erase it. Oop, all right, it is about 23,000, and those zeros are not significant. The 2 and the 3 are, and that's it. All right, a 0 written before the decimal point is not significant. If it's only a 0, it's a 0.5, it's a placeholder. All right, it just tells you it's less than 1. Okay, that 0 is not significant. Zeros after the decimal, but before the first non-zeros are not significant. So these zeros, again, preceding it are not significant, all right? Why is that? Because what if you were to translate this into milliliters? Do you remember how to go from liters to milliliters? You move the decimal place over 3 spots. Well, what happened to those zeros? They're not there. It's 4.5 milliliters, and that's only 2 significant figures. Why? Because it's a non-zero number. They are significant. But any number, any zeros preceding the first 4, the first one, the first digit will not be significant. However, zeros after the decimal and after the last digit, that's not a 0, are significant. Why? Because I measured this, and here's what, tenths, hundredths, thousandths, 10,000, 100. I measured this nearest millionth of a liter. My graduate cylinder or my whatever is so precise, it can measure the nearest millionth of a liter. So those zeros are significant. So let's just see something real quick. This has 3 sig figs, all right, the 5, the 0, the 8. This has 2 significant figures, the 2 and the 3. Why? Because these zeros are not significant. This has 1 significant digit. Why? Because that 0 is not significant. This has 2 sig figs. Why? Because these are not significant. And this has 4 sig figs. Why? Because these are not significant, but these are significant. Oops, there we go. They are significant. All right, so what we're going to do is practice, okay? All right, so what about 35,000 liters? Is there a decimal point here? No, those zeros are not significant, so there's only 2, all right? How about number 2? How many significant digits are there? Are the zeros significant? No, they're not. It's like number 4 up here. Those zeros are not significant. They're placeholders. So only 2 sig figs, the 8 and the 5. Well, 12 inches in a foot. How many sig figs are in the 12? It's not 2. It's infinity. Why? This is a definition. About number 4, 0.004800. Well, how many sig figs are there? 4. Why? These first zeros are not, just like right here in this number 4. The zeros after the decimal before the first non-zero are not significant, but the other ones are. That's your number 5. 207, how many? There's 3. Why? This 0 is significant. It's between a 2 and a 7. And how many significant figures are number 6? 3. This first 0 is not. So what I'd like you to do now is try the next 6 and see how you do. All right, let's see. I'm going to scroll it down here. This has 1 significant figure, it's the 9. Pi is just a number, so it's infinity. Number 3 is 2, the 1, the 5. It's a non-zero digit, it will be significant. This is 50.00. They all are significant. So it's like I have a graduate cylinder that can be read to the nearest hundredths, and it's smack dab on that 50 mark. Okay, so all 4 of them are significant. And number 5, all 6 of them are significant, even these zeros, because it tells me that my scale can go the nearest 100,000th of a gram. All right, that's kind of tenths, hundreds, thousands. Oh, sorry, 10,000th of a gram. I can figure out my placeholder there. And number 6, it is 3, and the 1, the 5, 0.0. So that 0 is significant because my ruler can measure to the nearest tenth. Okay, so there you go. Let's go to the next page and talk about rounding. All right, so if you are going to round to a certain digit, you look at the number that directly follows that position. If it's greater than a 5, round up. If it's less than, or if it's 4 or less, you round down. Or you don't really round down, you don't round at all, I should say that. So just drop everything, okay? Now, number 2 is super duper important. A lot of people forget to do this. It says, remember to maintain the place of that digit. Don't drop any zeros that are placeholders, okay? So I want to go around this value 6 that I underlined, okay? So how would I read this number? This is 456,500. So this 6 still needs to be in the thousands place if I don't round, but I actually do have to round. So the spot that I underlined is in the thousands place value. So I need to show that my answer still has, those thousands there. So do I round that 6 up to a 7 or not? And the answer is, well, yes, you do. And so you get 457,000. So if this is in the thousands place, this should be in the thousands place. What is so easy for people to do is just make it 457 and forget all these zeros. Your number is totally changed if you drop your zeros, okay? So what about letter D? I want to round to the nearest, tenth, hundredth, thousandth. I want to round to the nearest thousands. So what happens? I look to the next digit, and it's an 8, so I have to round up. Well, what's 1 digit more than a 0.009 is 0.010. Notice that this is in the thousandths. This 0 is in the thousandths. All right, so that is correct. What about the next one? 0.0000145. Do I round up? No, but I still have to have that in the right position, so I leave all those zeros out in front. All right, what about this next one? I want to go the nearest 10,000ths. So what do I look at? I look at the 4, And is it going to round up or not? No, you're not. You're just going to leave it 0.0098. Okay, so what position is the 2 in? Well, what is this number? It's 129,999,999. So the 2 is like in the 120 million area. All right, so I have to be like in the 100 something million area when I'm done. So what happens, that 9 is going to round it up. Oops, sorry about that. And I'm going to do this. And so notice the 3 is still in the same place value as that 2 is, but I had to round up. And last but not least, the 7, I guess I didn't underline it, but it's supposed to be bolded, all right? So it's the 7 I want to round. So do I round up? Yes, I do. So it becomes 80. So why isn't it 80.00? Because I want to round to the nearest tens, all right? If I put a decimal place and make it 80 point, then I've made it to the nearest ones. So 80 is in the nearest tens. And don't worry, we'll be practicing this, but I'm going to leave you here and we're going to do another video for the calculations, all right? So don't wait to be great. Take care. Bye-bye.